Welcome students to another lecture on real analysis, in which we shall prove that limit x approaches to 0, x square sine 1 upon x equal to 0 by delta epsilon definition. First I write delta epsilon definition, which is if we have a limit x approaches to a, f of x equal to L. Now this limit implies for any epsilon greater than 0, we have a positive real number delta greater than 0, such that condition is when x minus a mod is less than delta, then f of x minus L mod is less than epsilon. So this is our delta epsilon definition. Now we try to apply this definition on given question. So our question is limit x approaches to 0, x square sine 1 upon x equal to 0. Now we have to prove this limit by delta epsilon definition. Now if we try to apply this delta epsilon definition, whenever you are dealing with questions of delta epsilon definition, first start with this relation x minus a mod less than delta, then try to establish a relation between delta and epsilon by using f of x minus L mod value. Now consider x minus a mod. X minus a means x minus 0 mod is less than x minus 0 mod is less than delta. We start with let x minus 0 mod less than delta. From here we can write x mod is less than delta. This is our equation number 1. Now we try to establish a relation between delta and epsilon. For epsilon values, we solve this modulus value, that is f of x minus L whole mod value. For f of x we have a function x square sine 1 upon x, and for L we have 0 value, which implies f of x minus L means x square sine 1 upon x minus 0 whole mod. Now this is equal to x square sine upon 1 by x whole mod. By using property of modulus function, we can write it as x square mod and 2 sine 1 upon x mod. The reason is since AB whole mod is equal to mod of A and to mod of B. Now we can write it as x square mod is equal to x mod whole square and sine 1 upon x. Now we try to apply equation, use the relation in equation 1, which is x mod is less than delta, and we have another relation which is sine 1 upon x, or we can write it as sine x whole mod, this is less than or equal to 1. Now we have this relation, and in equation 1 we have mod of x is less than delta. Remember, this relation for sine holds for all the values of sine, means in place of x we can use any relation, sine x, sine 1 upon x, sine y. So for any argument of sine we have sine x mod less than or equal to 1. Now by using these two relations we can write, which implies x square sine 1 upon x whole mod is less than x square mod, x mod square means delta square, as x mod is less than delta, and sine 1 upon x is less than or equal to 1, which implies x square sine 1 upon x mod is less than delta square. Remember, we need a relation between delta and epsilon. If we choose epsilon equal to delta square, then delta is equal to epsilon under the root. Now by using this value of delta we can write, which implies x square sine 1 upon x whole mod is less than delta square, means epsilon under the root square. Square root and square cancels out, so we left with epsilon, which implies x square sine 1 upon x whole mod is less than epsilon. Now for epsilon greater than 0 we have delta greater than 0, such that whenever x mod is less than delta or x minus 0 mod is less than delta, then f of x minus L, which is x square sine 1 upon x minus 0 mod value, and which is equal to x square sine 1 upon x, this is less than epsilon. Now by delta epsilon definition we can write as limit x approaches to 0, x square sine upon 1 by x is equal to 0. Hence proved, and this is our required result. Thank you very much for watching this video lecture. If you want to watch my other videos on real analysis, you can visit my playlist. Thank you very much.